Fuel and Emissions Test 6. We're talking about temperature and position sensors. You know, if you think you understand temperature and position sensors, you might or you might not. So there's worksheets you need to avail yourself of on this, and you need to dig in there. It won't take all that long to take a TP sensor, measure resistances, and go and do the stuff they say on the sheet. Every sheet counts, guys. You know what I mean? Every sheet counts. You know how that is, don't you, Willie?
Yes, sir.
All right. Now, midterms are a week from today as far as the grades are due. I was going to give an exam. I told Daniel via text that I've pretty much decided just to let everybody's grade fall where they are instead of giving an exam, because it's too much trouble to fool with having to rush and hurry, and everybody, it takes you away from the work in the shop, and you have trouble grading that stuff and all that kind of thing. Really, I'm going to tell you something. A short answer test is tougher to grade than a multiple choice test. And the reason is because I have to read every word, and if I can tell you knew what you were talking about, you see, I can't penalize you for using the wrong words necessarily. If you knew what you were talking about, I got to give you credit. But then I got to read a heck of a lot of answers and think a lot more than just doing A, B, C, D, and all. I'm a lazy instructor, right? A sensor that most determines fuel delivery when a fuel-injected engine is first started is what? Engine coolant temperature sensor does. Let's get that parsed in a minute. Here, let's look at this. We're going to have your crank sensor. How does the crank sensor play where the fuel injector is concerned? What's up with that? You guys, somebody explain this to me. I mean, what in the Sam Hill the crank sensor got to do with the injectors? I mean, this was when I first started to understand fuel injection.
It tells when each cylinder is on top dead center, or
actually, the crank sensor tells the computer exactly where the engine is within its 360 degrees. It cannot tell which cylinder is on top dead center compression versus exhaust without a chem sensor. You got me? Now, you remember that distributor I got up there that's got the vanes and the Hall effect sensor? One of the vanes is wider than the rest of them. They call that signature PIP, profile ignition pickup. Now, this turned in at half crankshaft speed, and whenever that narrow vane came around, it actually gave it information based on which cylinder is at top dead center compression, and so it would know exactly which injector it needed to squirt, right? And what's the point in squirting an injector, you know, when the valve is open? You know, it's going to have fire, and also, yeah, you want it to spray the fuel right before the intake valve opens so the fuel can be carried in. Anyway, the long and short of it is, as far as injector though, how is the crankshaft, if he said timing, but how is the crank sensor related to injector operation? You know me? You understand what I'm saying? If I was going to say, well, let me just try to explain it the way I explain it. I mean, y'all might not even know what I'm asking you for. I'm cranking the engine, and it is cranked and it's running, right? I mean, we're going to get the starting part out of the way because it's a slightly different deal. And as the engine is sitting here, you might even have listened to the injectors. How many of you have listened to injectors with a stethoscope? Click, 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 click. All right, as you gas the engine, it goes click, 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 it gets faster, right? The crank sensor is causing it to fire the injectors more frequently. Now, it'll put some renegade squirts in between those standard pulses if somebody cracks the throttle, because it needs an injector. I mean, it needs a throttle, you know, the accelerator pumps, what I'm trying to say. Accelerator pump squirt is simulated by adding additional injector pump squirts in between the ones. So basically, you've got to have, and I'm just drawing the line like here, you're going to have these happening real regular. Right? I'm not even talking about pulse width yet. I'm talking about we're going to fire the injectors based on crankshaft speed and position. And that's cam and crank sensor that does that, or PIP. They did away with the profile ignition pickup on the Fords when they put in 1993 they put a cam sensor on the Tempo, and they put a distributor in there without profile ignition pickup. And if anybody happened to put a distributor in there that did have profile ignition pickup, it would fit, but when you crack a throttle, you drop cylinder number 3. And that will beat you up if you don't know what's happened. Because I've been there, guys. All right, now what? So I'm going to take this thing, and I'm going to take each one of these pulses, and I'm going to modify it based on what? That pulse is modified based on what?
cranks.
Huh? No, the crank determines when the injector clicks. When the injector clicks, the amount of time that injector is open, and there's enough time in there, there's enough of a window in there. There's enough of a window in there to where it can actually expand or contract that injector pulse based on inputs from something. So what is going to change that? What's one of the things you can think of that most obviously is going to make that pulse wider and make the injector deliver more fuel every time it squirts? If it's cold, you got an engine coolant sensor. What about intake air temperature? If the air is cold, it's going to have a little bit more. Because if you got cold air, you need more fuel, right? Why do you need more fuel with cold air? Denser air, because there's more molecules of oxygen in a cubic, inch of cold air than there is in a cubic inch of hot air. That's why people put cold air intakes on their cars. They want to cool that air, make it really cold. All right, don't let your eyes glaze over with it. All right, now then, what we got right here, we're changing it. What's something else that changes that injector pulse? There's other things that change it besides engine coolant and
did you just say the increase of speed?
Yeah, the speed is actually the speed has got to do with the number of times the injector fires in a given period of time. If the engine is running at 700 RPM, the injectors are going click, 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 like that. All right, let me ask you this. If it's a V8 and it's idling at 700 RPM and it's sequential fuel injection, how many times per minute is that injector clicking?
70.
Huh?
Well, now there's
45.
The number 1 injector, the number 5 injector, pick one.
Well, there's 3 different types of injection. There's one where all of them fire at the same time.
That's when you're spinning it.
Companions.
Yeah, or that's when that's basically what you're talking about is whenever you're starting it up, it's flushing a lot of fuel in there to wet the manifold. That's only when you're starting it.
Well, then there's some that companions will go together, and then there's some where it's every one.
Various different ones. But all things being equal, if it's sequential and it's just firing them one time, I know where you're going, but
and it's firing once every 2 revolutions, right?
It is. It's gonna be firing. The injector doesn't. The speed of it's gonna pick up with crank speed, but it's not gonna fire. It's not gonna squirt fuel every time that piston comes up, is it?
No.
No need to. Huh? Every other time. And so number 1, how many firing events are there? Every 2 times the crank turns. Now how many times you're measuring every time the crank turns? Every 360 degrees. That's one revolution. Okay, it's turning 750 times in a minute. Let's say you're idling at 750. Okay, in that minute of time, how many times does the number 1 fuel injector click?
375.
You're going for half, right?
Yeah.
So it's going to fire every other time. How many firing events are there in 720 revolutions? In other words, 720 degrees. How many firing events are there on a V8 in a 720 degree?
There'd be 8.
That'd be 8. Yeah, that's right. That's smart. Okay, how many degrees are there between firing events? Well, what I'm trying to get to is how many times does the number 1 injector fire during the 360 degree? Is it going to fire once? Or is it going to fire every other time? And we're talking just 1 injector, not all of them.
Well, every 90 degrees you get
a firing, yeah, that's right. You got a firing event every 90 degrees in a V8. Every 90 degrees, you got a firing event in a V8.
So 1 cylinder is only going to do it once every 2 revolutions.
Yeah. So basically you're going to go once every 2 revolutions. So that particular cylinder is only going to operate half as. And he got it right. But it's half of 750, which is 375, isn't it?
I don't know.
Didn't you say 375?
I think that's what I said.
That's what you said, 375. So the injector is going to click 375 times in a minute.
pretty ridiculous.
Yeah, isn't that something? My dad used to think this way. My dad would tell me, he said, when this particular engine is driving down the road at 60 miles an hour at such and such an RPM, this valve is going to open 4 times a second. He was always figuring that stuff in his head all the time. He was always coming up with that, and it just boggled my mind, And then when he went to get his GED, he understood algebra so well that he taught the rest of the class while the teacher sat over to the side. He was just sharp on that stuff, and he quit school when he was in the 10th grade. But he really was good at algebra and stuff like that. Anyway, I'm just trying to make sure everybody gets to burn this in, guys. You got to understand what's going on under there. This thing's going click, click, click. Okay, it's being modified by engine coolant, intake air. What else? What about altitude compensation? For this coming from your map or your mass airflow. Altitude compensation is going to modify it, right? It's going to narrow the pulse width as you go to a higher altitude. Okay, and it may not, I mean, you don't know exactly how much, but you know, you're actually splitting hairs if you get down and start measuring the pulse width, because it's real tiny, because you got, you know, 3 or 4 or 5 milliseconds, which is thousandths of a second. Okay, what else modifies it? What could make it spread out really wide all of a sudden? What if you, if you goose the throttle, it's going to spread out just because you did that, if you go quick. Because that's one of the things it measures is how fast is this guy applying the throttle. See, all the stuff's going to be factored in by these programmers. Okay, something else you're looking at is engine load. If it's one of this using a map sensor. You're also looking at airflow. You see, it's going to change that based on airflow. And if your airflow is not being reported right, it's going to impact that. I have seen mass airflow sensors that you say, well, I'm used to looking at these things, and whenever it's idling, if you're looking at the voltage, it's about 810 millivolts at that thing. I'm looking at, and I'm not looking at grams per second, I'm looking at millivolts, because that's really a fine deal. I'm saying, okay, 810 millivolts, but this one here's got fuel trims that are very positive, and on this one right here, I'm seeing 790 millivolts. That's not a lot of difference when you're talking about a window from just under 1 millivolt, just under 1 volt to about 4.6. And we're talking about just a very few millivolts. And I've actually seen that fuel trim be way out of kilter to the positive side because the mass airflow sensor was reading 790 millivolts when it should have been reading 810 at idle. And if you pop a different mass airflow on there that's calibrated properly, cleans up its act, fuel trim comes back to 0, you're in Fat City.
Is that what happened with your daddy's tempo? Or?
My dad's tempo had a doggone, it was throwing a code. It was worse than that. My dad's tempo was, it was bucking and jumping and throwing a code. And we put that mass airflow sensor on it, and it didn't change anything. And so I unkeyed those things out and soldered the little joints, and it took care of it. We've had to solder those little crimp joints on throttle position sensors to keep them from running away at idle. You pull up to a stop, you like on a standard, put it in the air, mash your clutch, and it's sitting here going, still holding the idle up. What the Sam Hill is this? When you look at your scan tools, it's part throttle. When you crank the car, whatever it sees is what it's going to peg as idle. That's why you ain't supposed to be jacking with your gas on a fuel-injected engine when you start it, because it gets confused about where closed throttle is, see? And whatever it sees when you start it, and it's supposed to be a no-touch starting, your idle air control, supposed to open it up. If the computer's in control of an electronic throttle plate, it knows where idle is because it's going to check it, Just like that. The electronic EGR is the same way. It's going to bump that to see where it is. Two technicians are discussing what happens to the voltage measured to the engine coolant temperature sensor when the thermostat opens?
Does it increase slightly?
Well, yeah, he sounds like he knows what he's talking about over there. How can you look at your scan tool and tell when the thermostat opens? The coolant goes up and up and up and up, and when the thermostat opens, the voltage goes down. Not the voltage, the temperature goes down, but the temperature goes down, that means the voltage goes up. So as its negative temperature coefficient, it goes down, the voltage goes up. And in other words, the temperature goes down because the voltage goes up. Two technicians are discussing a stepped engine coolant temperature circuit. Technician A says the sensor used for a stepped circuit is different from the one in a non-stepped circuit. Technician B says a stepped ECT circuit uses different internal resistance inside the PCM. What in the Sam Hill are they talking about when they talk about a stepped circuit?
It's to get a more accurate reading, and
what does it look like on your scan tool though? You ever seen one?
It's going to go like this, and then
yeah, like I drew that on the board the other day. It's basically going to shift gears so it can tell more accurately what the temperature is at the higher temperatures. And there's a fair number of them that have that. Some don't though. That Oldsmobile has that. Jeeps have it, but most of your Ford stuff don't have it. Not all of them have it. If you've got one, you need to know that, because if you happen to be watching the voltage and it takes a crazy jump, and you're thinking, oh, we got a coolant sensor problem, you can put a part on there that's not required or not called for. If you don't understand that this is a stepped one, that's why you need to do a look at your description and operation section of your shop manual. One of the high school students this morning, I was sending him to do some research on a vehicle for a worksheet, and I says, what are you doing out here winging it whenever you didn't even look it up? He says, I don't do well with books. I won't get my hands on it. I don't need that shop manual. Start taking the door panel off of a car and break a $1,500 door panel because you didn't look at the shop manual. Somebody will be, you know, sending you a bill. Okay. Let me see. When testing an number 3 is a B. 4, when testing an ECT sensor on a vehicle, a digital multimeter can be used in the signal wire tested with a connector attached with the ignition on, engine off. What settings should this technician use to test the sensor?
You gonna ohm it out?
No, you're actually, we got the key on now, you're going to have voltage there, right?
Sure.
Signal wire tester. You're at the signal wire on the sensor. What they're talking about here is your sensors here. I'm just drawing it real simple. You know, here's your wrench flats where you're going to put it on. You got 2. This one here is signal return. This one here is SIG. You know, this basically is a ground inside the PCM. This signal right here is going through a current dropping resistor inside the PCM. So as high as it's going to go, even if you unplug it, is 4.6 volts typically. So you're measuring right here with your meter.
To the ground.
What do you think? Who knows?
I'm gonna say it's gonna be DC volts.
It's probably going to be C. It's going to be DC volts. And it's not going to put out any kind of hertz. It's not going to put out AC volts. It's got to put out DC volts. That wasn't a hard question. But I wanted you to visualize what it was talking about. How many times are you sitting here and you don't really understand something, but you don't want to ask a question because you think I'll talk too long if you do? You know what I mean? He just yawned when I said that. Okay. Let's see. When testing the ECT sensor with a connector disconnected, the technician should select what position on the digital multimeter. Now you're testing the, and what they're talking about here is we're unplugging the connector, and we're actually going to be testing the sensor terminals ourselves.
Well, then you test it with on.
Yeah, that's the only way you're going to be able to do that. Maybe put some threads down here, a little bulb, whatever. All right, so there that is. Okay, so that's number 5, isn't it? And 5 is C. When checking, you know, Ford used to have us check the resistance of that sensor with the engine at a certain temperature. I think that's the dumbest fool thing I ever heard. Why don't we just back probe it with the engine and run and see what the voltage is? And then I sent in a best ideas contest thing about that, and the next year the shop manual came out with them checking voltages and everything. I don't know if it was a color what I put in there or not, but it's just a smart way to do it, you know. Check the good ones, you'll know what the bad ones, you know, when the bad ones don't look right. When checking ECT sensor with a scan tool, what temperature should be displayed if the connector is removed from the sensor with the key on, engine off?
40.
Turn on the key, unplug it. Yeah, and there's a qualifier that should be there. If you're looking at the scan tool in your enhanced mode, if you've selected the vehicle and you went into the one for the, you know, Chrysler, or a Chevrolet or Ford or whatever, you're going to unplug it, and you may see a substituted value that they think will work, like 100 degrees or something. But if you go into the OBD2 room, you'll see 40 below. OBD2 room never lies to you about what it's reading. The enhanced room will. If you always go into the enhanced room, you got an engine coolant sensor that's not right. If it's about 90 or 100 degrees outside, and you switch that thing on, and it's open, and it has substituted 100 degrees, and this one here is 98, and that one's 100, you're not going to catch it, are you? Now, you may pull a code or something, but you're going to say, I don't understand this. It's reading just fine. But where you see the difference is if you have a cold snap and it's 40 degrees, and you switch it on without starting it, and the IET is reading 40, and the engine coolant temperature is reading 100, and it ain't even been started. Then you go into your OBD2 room, you find out it says 40 below, and you say, crud, somebody's got this sensor unplugged or the wire's cut or something. All right, so always remember that, and I had to qualify that because your scan tool is not always going to say 40 below when that thing's unplugged. Sometimes it'll substitute a value if you're in the enhanced room. 2 technicians are discussing the IET sensor. Technician A says the IET sensor is more important to the operation of the engine, higher authority, than the ECT sensor. Well, what vehicle are they talking about? What system are they talking about? Technician B says the PCM will add fuel if the IET indicates incoming air is cold. So who's right about that? B is right about that. Now, one of the things that these people try to do is they try to say on all engines, this one sensor takes authority over the other one. Well, it depends on who wrote the software, which vehicle it is, and what year model it is. On some of the Jeep stuff that I used to work on, if you unplug the intake air temperature sensor, all that would happen is you'd get a little bit of a stumble when you accelerated. It wouldn't make it run rich. But on other cars, some of the other older cars, you unplug the intake air temperature sensor or it goes open, you're puffing out black smoke to beat the band. So it's not always going to act the same way. You can't go say, if I unplug, engine coolant temperature takes precedence over intake air temperature because, like I say, the software wasn't typed by the same people on all those cars. And some of the engineers thought one was more important than the other. You better be checking the one you're looking at. And there's not any fast, hard rules there in most cases. I mean, it's moving in one particular direction today, but I'll leave that for your own study. Number 7, the right answer, if you want to get it right when Katie grades it, is B. A typical IAT or ECT sensor reads about 3,000 ohms when being tested using a digital multimeter. This resistance represents the temperature of about what?
120 degrees?
Well, anybody else want to weigh in on that? That's going to be 70 degrees. That's a 70-degree temperature. That was a good guess, though. If the transmission fluid temperature fluid sensor, TFT sensor, indicates cold automatic transmission fluid temperature, what would the PCM do to the shifts?
Delay shift points, torque converter clutch disable.
Why does it want to disable the torque converter clutch if the fluid's cold?
Indicating that it's not on.
No.
It's not at operating temperature, which means you're not really in high enough gear to be watching out for.
I know, but I just cranked it up and I'm already at road speed.
So,
And it's not going to lock the torque converter up. I mean, you were talking about speed just a minute ago. I mean, cold engine, I mean, what's wrong with let's say my transmission fluid temperature sensor goes sorry and it's reporting cold fluid all the time. It doesn't lock up the torque converter. And the shift points are delayed. And if it's an in-range failure, you may look at it with your scan tool and not know you got a problem there. It ain't going to throw a code if it's an in-range failure, is it? So you got a problem without codes. You got a transmission oil temperature sensor that's lying to you. You remember what Katie's engine coolant temperature sensor was doing on her Mercury Mariner? You remember that? It was telling us it was colder than it was. I mean, this thing was running at 210, and it was telling us it was at 150 degrees, 60 degrees colder, but it was an in-range failure. The code that it was throwing had nothing to do with the engine coolant sensor, so we weren't led in that direction. We popped a thermostat in that thing because it said it was a PO128. And so Lee stuck a thermostat in there, like a second-rate amateur. I don't know what he was thinking about. And this darn thing still threw the same code. And Katie said, "What's up with this? We put a thermostat in here, we still got the same code?" And then we got to do the temperature gun comparison. Here, the reason we don't lock up the converter when the transmission fluid is cold is we want to heat the transmission fluid up. And if you lock up the converter, you ain't making no heat. Where does the heat come from? It comes from the torque converter, right? You guys remember that from transmissions. The heat in automatic transmission is made by the torque converter. If the torque converters lock up, is the torque converter cutting through that fluid making heat? No, it's not. What about the motorhome? You know when a motorhome torque converter locks up? The F-53 chassis or whatever, the big motorhomes, they lock in at 22 miles an hour. Now, why do they do that? They lock in at 22 miles an hour to keep the torque converter from heating the fluid up too much, because that big old heavy thing is hard to pull, right? All right, so remember that. If you want to heat the fluid up, you're going to let that torque converter cut fluid. You're not going to lock it. When you lock it, everything's hooked together. It ain't shearing fluid anymore. It's not creating heat. Ask Matt about that. Okay. Is your eyes glazing over? Got your pen? Okay. Now we're going to go to, we've only got 677 questions left to go. That's like when you're down at the government office and they say, okay, you're number 48. And then as you walk away from the window, he goes, number 3. All right, I'm kidding. PO118 diagnostic trouble codes being discussed. Technician A says the engine coolant sensor could be shorted internally. Technician B says signal wire could be open. What do you think about that? What's a 118?
B.
A technician B, signal wire could be open. I mean, somebody got it clipped it. Technician A says the ECT and IAT sensors can be tested visually as well as by using a digital multimeter or scan tool. Technician B says the ECT sensor is a high authority sensor at engine startup and is used for open loop control as well as idle speed. Which technician is correct about that?
So they're both right.
It's going to be Charlie. Which of the following components provides engine control component computer? Which of the following components provides the engine control computer with engine coolant temperature information? And that is the dumbest, stupid, fool question I've ever seen in my life. The engine coolant temperature sensor. Why don't we just try to come up with a question that doesn't make any sense? All of the following are approved methods for diagnosing an ECT sensor except what? All right.
DC.
Actually, substituting a variable resistor. Now, that's not a bad practice. It's just not going to tell you if the ECT sensor is bad or not. You know what I'm saying? Because I substitute a variable resistor sometimes. You know, I told you about that Dodge. It wouldn't start because they had a cold snap and the intake air temperature sensor was reading 101 degrees. That's what it was using. And it was actually reading wide open. And so I noticed the ECT sensor was reading 40. Truck hadn't been started. And this was reading 110, so I hooked a variable resistor in there and I dialed it down to where it matched the ECT sensor and it fired up. Which it wouldn't start before that. But see, in the warmer weather it would start because the 100 degrees that it was substituting was close to reality. But whenever the ECT and the, if the ECT got cold and the intake air couldn't follow, we had a problem there. Alright, let me see here. Let me see right here. All the following are approved methods for, never mind, 14. Technician A says all temperature sensors decrease in resistance as the temperature increases. This is called what? Positive temperature coefficient? Is that? Negative temperature coefficient. Technician B says some vehicle manufacturers use a stepped ECT circuit inside the PCM to broaden the accuracy of the sensor. Who's correct on that? B is right on that. B is right. Technician A says other temperature sensors that operate like the ECT include transmission fluid temperature, engine oil temperature sensors. Technician B says all temperature sensors increase in resistance as the temperature decreases. Do these guys know what they're talking about? A does. A actually knows what he's talking about. Yeah. I was telling Daniel the other day that a light bulb increases in resistance as the temperature increases. You turn it on, the resistance goes way up. That's positive temperature coefficient. Just think of a light bulb being the opposite of an engine coolant sensor, okay? Technician A says other fluid temperature sensors operate like the ECTs, stumble over my teeth here, include transmission fluid temperature, engine oil temperature sensors. Technician B says all temperature sensors increase in resistance. Well, I just read that question, but I wanted to say something to go with it. And I've said this before, but always remember, whenever you go into your scan tool, if it's setting all night, all the sensors ought to agree within a degree or so. Transmission oil temperature, intake air temperature, engine coolant temperature sensor, any other temperature sensors you happen to be looking at. If it's got an ambient temperature sensor you can read on another part of your scan tool, they all ought to agree. They ought to be real close. And what is it that makes them do that? Scientific principle. You know? Anybody know? Joe, are you asleep? The second law of thermodynamics is what causes it. Okay, and you can study that too. Okay, 16. The sensor that measures the temperature of the air being drawn into the engine is both A and B. Yeah, see, that was a trick question. You might just put A. Sometimes I'll miss one when I do that. I'll machine gun it. I'll see intake air. Poop, that's it, without reading the rest of it. 17. A PO 113 DCC is being discussed. Technician A says the IET sensor could be internally or electrically shorted. Technician B says the PCM could be defective. B. Right? Yeah. Okay, now PO 117 DTC is being discussed. See, that's your DTC table in front of you to see these, and the book's got that. Technician A says the ECT sensor could be internally shorted to ground. Technician B says the signal wire could be open. Who's correct about that? That's going to be number 18. That's going to be A. Let me tell you, if you've got on some cars, if you've got the 3-wire sensor shorted to ground internally, like if 5 volts has been pulled to ground, the vehicle won't start and the scan tool won't talk. So keep that in mind too, because there may be a bug in your future. He likes to chase bugs, don't you, Daniel? He wants to be a bug chaser. All right. Now then, let me see. An IAT is being tested. Intake air temperature. After the vehicle has been allowed to cool for several hours, the scan tool is used to observe the IET and compare the engine coolant temperatures. That's what I was talking about earlier. The two temperatures should be within how many degrees of each other? 5 degrees. Now, if it's been sitting out in the sun, and the sun's been beating on the hood, and it's warmed up the engine compartment, you know, you may see some difference there. Transmission temperature sensor may be a little different. Technician A says the purpose and function of IET sensors provide engine computer with the temperature of the air entering the engine. That's smart. Yes, of course it is. Technician B says the IET sensor information is used for fuel control, which adding or subtracting fuel, and spark timing depending on the temperature of the incoming air. That is C. That is C. See if that air conditioner's on or if it needs to be turned down. One of you guys, somebody, anybody, pick it up. Check it out. Because it should be, usually it's kicked on by now. 21. Now 20 is actually going to be C. Which sensor is generally considered to be the electronic accelerator pump of a fuel-injected engine?
C.
C.
You know, what are you moving? The TP sensor, right? Wigwam indicator. Was it turned off?
Yeah.
Okay, I wondered about that. I wonder who did that. That's not smart. Usually, when it gets turned off, somebody that's cold-natured does that, and nobody in this room is cold-natured. But there is somebody in the next room that is. I think. I could be wrong. All right. Now then. Typical TP sensor voltage at idle is about what?
1.5 to 0.8.
Yes, but the people that write these tests and they could put that voltage there, these people are really GM strong. I mean, they think GM is the only people that do anything. On a GM, it's a half a volt. Got me? On a GM, it's a half a volt. On a Ford, it's 1 volt. Pretty close. Got me? But a half a volt's what it is on a GM. TP sensor is what kind of sensor? Huh? Rheostat, piezoelectric, potentiometer, or voltage generating?
Potentiometers.
That's a pot. Most TP sensors have how many wires?
3.
3. I've drawn a zillion of them things on the board up here. Which of these sensors does the TP sensor back up if the PCM determines a failure has occurred?
Mass airflow.
Either B or C. The MAP or the MAF. And you got a growing number of vehicles out there now that have both mass airflow and MAP. Why do I want a mass airflow and a MAP? I mean, can you think of a reason? I mean, if I'm an engineer, why would I put mass airflow and MAP? There was a time, you know, General Motors came out with mass airflow sensors in about 1985, about the same time they came out with, I say in 85, it may have been a year or two on either side of that, but it was roughly the same time they came up with qual pack ignition. And those sensors were so sorry that the way that you would troubleshoot them was you would wrap them with your knuckles, and if the engine ran bad, you'd put a sensor on it. And they got so much trouble with that they went back and they retrofitted some of them. They put MAP sensors on. All right, now let me say something about this. This is pretty important because we're getting into mass and stuff like that, TP and MAP sensors and all. I was going to tell you we got a Mustang engine that somebody stuffed in a Bronco. You know, old Bronco, you know, like Pernelli Jones won the Baja with. So he stuffs the Mustang fuel-injected engine in puts a cam in it. You know, makes it go rough running idling cam. And he's got everything, all the electronics and everything off that old Mustang, and he puts it in there. You know, he's got his MAP sensor, and he's got his, you know, he's got a fuel supply and all that kind of stuff. But this thing's running rich as a dog at idle. So why is it running so rich at idle? It just, I mean, it's puffing black smoke, something terrible. And the only thing he changed, other than stuffing it in a Bronco, was he put a cam in it. Now what does a cam do to the engine vacuum? You guys are really asleep this morning, aren't you? If I put an aggressive camshaft, what's the engine vacuum going to look like? It's going to be lower. If the engine vacuum is lower, what's reading that engine vacuum? MAP sensor is reading the engine vacuum. Because the MAP sensor is reading the engine vacuum and it's seeing a low engine vacuum, it thinks the engine's under a load. So the computer sees that little thing in its algorithm and it says, we're under a load, so we're going to dump some extra gas in there. Now when you're up at road speed, the vacuum's up. Got me? Everything's fine. But idling, so how you going to fix that, guys? This guy spent $28,000 on this thing already. So we're going to fix that. We've got to take care of that problem. What we're going to do? Anybody know? You're the part salesman, Lundy. Talk to me, buddy. You got to sell this guy a part. It'll help your numbers at the end of the week, you know.
Are we gonna recommend him a new map sensor, like a different one that's for his build?
That's a good guess, but it's not feasible, so it's not available, so forget that. Don't work. Huh?
I'd be looking at the vacuum.
Hey man, I'm going to talk about putting a mass airflow kit on that bad boy. Because mass airflow is going to tell the truth. I can't believe that somebody didn't come up with that answer. Because that was the answer I came up with. And it worked. Now it was $500, but it fixed it. So the reason is because the mass airflow couldn't care less what the manifold vacuum is. All it's measuring is incoming air. And this little sucker was cool because they had a little LCD screen you could put over here that was, the wires were going through that, a little adjuster, and you could actually use that like a tune it with a screwdriver and set that mass airflow just like you wanted it to be, so that it would run so smooth. It was almost like just in your carburetor, you know. Anyway, that took care of it. He had no more black smoke. That was a little exercise. I was just trying to get you guys to think fairly. Usually if we stay in here this long, people start trying to turn into a skeleton. But we haven't even been in here 40 minutes. You shall not surely die, you know. All right, so, right, now we got here, we already got that. Mass airflow and map are backed up by the TP. Which wire on a typical TP sensor should be back probed to check the voltage signal to the PCM?
Signal wire.
Signal wire. And you got to find out what color that is, which one it is. You can usually kind of figure it out if you got to be gentle with your back probe. If you don't want to poke a hole in the wire, how many of you guys poke a hole in the wire? It ain't a good thing to do. I mean, I'm not going to say I've never done it, but I don't like it. I don't like poking a hole in the insulation on the wire. Let's back probe that thing. Get something slippery. T-pins, you can back probe with those or something like that, but whatever. So after a TP sensor has been tested using the min-max function on a digital multimeter, a reading of 0 volts is displayed. What does this reading indicate? You know what the min-max function on a digital multimeter is? It's actually going to record the lowest voltage and the highest voltage that has been seen during the session that it's recording. All right, something happens, you punch your min, max, and average, and it's going to give you a min that went to 0 or whatever.
That's D then?
Huh? Yeah, so number 27 is A, basically. The TP sensor is open at one point during the test. Now, that is kind of not really all that slick either, because if it's open, where is the open at? I mean, it can be, they can either go to 5 volts or it can drop to 0, depending on where the, where it's shorted in that strata. After a TP sensor has been tested using the min-max function, a reading of 5 volts is displayed. Number 28, what do you think? Both B and C are possible. It's either shorted to 5 volt reference or it's shorted. Somebody's out there talking. A technician attaches one lead of a digital voltmeter to the ground terminal of the TP sensor and the other meter to the lead to the negative terminal of the battery. The ignition is turned on, engine's off, and the meter displays 37.3 millivolts. Technician A says this is the signal voltage and it's a little low. Technician B says the TP sensor ground circuit has excessive resistance. Who's right about that? Anybody know? Huh? What letter did you say?
B.
You understand what we're doing?
Checking the ground.
Yeah. Here's your TP. You got 3 wires right here. Okay. Here's your PCM. 5 volts. Sig. Okay. Sig return. Did I do that right? See those 3? All right. Now let's look at where it's doing it. 1 inch to the ground, 1 to the ground terminal of the TP. Okay, we're going to attach 1 right here. Let's say we've unplugged this. And we've attached 1 right here at our meter, set on volts, and we attach the other one to engine ground. All right, now we turn the key on. Got it? Engine off, key on. And right here, we're reading 0 point. Is that, what did I say? Hold on a second. 37.3 millivolts. Got that? All right, what is that telling us exactly when we do that? This is grounded. It's supposed to be grounding this inside. But if you're reading voltage drop between here and here, that's going to skew these readings, isn't it? going to change the voltage that thing's reading. All right, just keep that in mind. So that's actually talking about number 29 is going to be what? Actually, that's not too bad, to tell you the truth. 37.3 millivolts is not bad at all. It doesn't have excessive resistance. It's got a little, but it doesn't have enough to hurt anything. Now, if you read a lot more than that, yeah. 30, a P0122 diagnostic trouble code is retrieved using a scan tool. And so what does that mean? We got a lot of code questions here. What do you think?
Well, what was 29? What did they want next?
29 is basically neither one of them. The 37.3 millivolts is not bad. I mean, it's not bad enough to worry about. But basically, there is some. But see, if that number went higher, like if it was 337, in other words, if it was 337 millivolts, it was too high. And you'd need to see about that. Now, what would you do about that? I'm going to check all these connections. I'm going to solder the terminal right here where it's crimped inside there. I'm actually going to go over here and I'm going to check this ground connection, make sure it's good, and all that. Because if it's skewed there, you need to check other ones and see if it's common to all of them or whatever. So basically, you're checking voltage drop on your signal return circuit. Everybody got that? Remember your voltage drop stuff? Who's checked voltage drop within the last 24 hours? Huh?
We did it yesterday.
Bingo. Look at these guys over here scratching their heads. We did it on that Honda out there, right? PO122, basically number 30 is going to be D. All of the above are correct. TP sensor voltage is low, could be shorted to ground. A signal circuit could be shorted to ground. Technician A says the 3 wires on the TP sensor include a 5-volt reference voltage from the PCM. Technician B says TP sensor wire is a 3-wire variable resistor called a rheostat, and it's not called a rheostat. A rheostat actually is the one that's kind of open-ended and changes the resistance of your going to your lights or whatever. TP sensor affects the operation of all of these except what? That's a good question. That right there would be like an ASC question there. ASC test question. Does it affect air conditioning compressor clutch operation?
I don't think so.
Does it how about torque converter clutch?
That's the transmission.
Rich and lean air fuel mixtures?
Yeah.
See.
Clear flood mode operation? Which one of them do you think is the least likely? Actually, correcting for rich and lean air fuel mixture, it's not going to correct anything related to that. It can cause problems, but it's not going to make a correction. When you go all the way to the floor with your throttle, the air conditioning compressor is going to drop out because you're needing power. If you're needing power, it's going to go into open loop fuel control. It's going to drop out your EGR. It's going to drop out air conditioner compressor clutch operation because you need power and you need a lot of it and you need it right now. Now, if you're driving a 3-cylinder Geo Metro, you're still not going to have that much power anyway, but that's what yeah, it's a 3-cylinder. That's what Adam Snap drives, that little red car he comes up here on. It's a 3-cylinder. You see them things.
Is this like a joke, like you're just messing with me?
Nope, not in the least. It's a 3-cylinder.
Really good at gas.
Look
You
it up.
have like pictures of this so I can see what this motor looks like.
It looks like a 4-cylinder, only with one cylinder. You've seen them, haven't you? You've seen them, haven't you, Lee? Yeah, he drove. See, listen to that. Lee's the man. You know what I'm saying? You led a sheltered life if you hadn't seen one of those, babe.
I've never seen a 3-cylinder. I've
Yeah.
heard the joke about a
It's got some really hot spark though, so don't let it fool you. If you check spark on it, it will knock you flat on your fanny. It was really hot spark on this thing. All right. I don't know how we got off on that. All right, now let me go down here to Technician A says the 3 wires on the TP sensor include reference from the PCM, signal wire to the PCM, and ground wire to the engine block. Technician B says the TP sensor is used by the PCM to determine the torque converter engagement and transmission shift points. He's right about that. 3 is B. B is the only guy that's right about that. You got me? Okay. 34. Technician A says the TP sensor signal voltage should be about 0.5 volts at idle and increase to 2.5 volts at wide open throttle. That's not right. What's it supposed to go to at wide open throttle? Somebody tell me. 4.5 volts, roughly like that, yeah. Technician B says a TP sensor can be tested using a digital multimeter, digital storage oscilloscope, or scan tool. Yeah, who's right about that? That's B. B's right about that. Did any of you guys read the little thing I posted on my technical writer page about the Pontiac Aztec this morning? And that was, I've seen that on more than one vehicle. The mass airflow could only report half as much as it was supposed to, and when you hit that threshold where it stopped increasing the mass airflow, you hit the ceiling. You were just not going. When you unplug the mass airflow, run like a race car, because it substituted TP. You got me? All right. Now then, the mass airflow sensor on a lot of cars too can keep them from starting. So keep that in mind too. And when in doubt, unplug the sucker. See what it does. Not gonna hurt anything, you know. Let me see here. Let me see. Oh, and a throttle. Can a throttle position sensor keep a car from starting if it's faulty? Can a faulty TP sensor keep it from starting?
Yeah, I think so.
How so?
It could be wide open.
There you go.
It could get locked wide open, right?
That's right. And what does that do?
I guess it'll cause it to flood out or something.
No.
You're throwing too much gas.
All right, Daniel, you're the thinker. What? How can a TP sensor keep it from starting? It can, but how can it keep it from starting?
Too much air?
No. What, the throttle position sensor?
Well, I mean, if it's stuck open.
No, what happens is if it's on wide open throttle, it's in clear flood mode and it doesn't operate the injectors. So if it's lying about that, I've actually seen that on some older cars. This guy had me come over to his house one time when I was still tinkering around, you know, doing stuff on the side a little bit. He said, well, Lincoln, you know, it's an old Lincoln that he didn't want to bring to the dealership because he didn't have no money. And I went over there and I measured the voltage of the throttle position sensor and it was reading wide open throttle. I unplugged it and it fired up. Ooh. Now, what you'll usually hear somebody say is, I put a little gas in there and then it starts up and I can drive it the rest of the day. But if I switch it off, it won't start back up until I put a little gas in there. Now, the reason for that is if it goes over 400 RPM, it starts off delivering fuel, even if the TP is in clear flood. You see, so you're pushing it past clear flood. You're putting fuel in that the injectors aren't.
Oh, it's clear flood.
Clear flood's like on your carburetor. You know, whenever back on your carburetors, when you had your kids had been playing with the gas and they flooded it, and you hold the gas pedal all the way to the floor so that the air going in there will dry the spark plugs out and it'll fire and start firing up. Clear flood is holding it all the way to the floor. You did that on carburetors and you do it on fuel injectors.
So there's a sensor for that now.
The throttle position sensor is what it reads.
Okay.
So basically, you push the TP sensor all the way to the floor. That's what they call clear flood mode. You guys have seen me do that out here. I would take this little Sonata or whatever, any car that's fuel injected, and unless there's gas puddled up in the manifold, you can hold that gas pedal on the floor, and it'll go. It won't start if you got that gas pedal on the floor. Now you can scare the daylights out of your girlfriend like that, guys. You know what I mean? If you can make that happen. You know, you go down to the burger barn or whatever, and and nobody's around, and they can help you or whatever. Oh, I guess I'm wise. Work on the car, and so some girls really impressed when you fix a car. So you act like you're doing something, and you go, "Ooh, yeah, that took care of it." You know what I'm saying? I told my but I mean, listen, you got to be careful because if there's fuel puddled up in the manifold for some reason, they'll start anyway. But if there's not, it will not start at wide open throttle. You can try it. Just be ready to let off the gas if it does start. But in most cases, unless there's gas it's getting from somewhere else, it ain't going to start if you hold that gas pedal all the way to the floor. You can test that on my car, a trainer car out here or whatever. Just don't blow the engine up on my trainer car like that other guy did. It threw 2 rods out of the Sable. But that wasn't clear flood. He was giving it gas. All right, let me see here. 35. Typical TP sensor registers how many volts at wide open throttle. 4.5 volts is right for that. A blank is a variable resistance sensor with 3 terminals. Potentiometer. The third terminal of a potentiometer is attached to a movable contact and slides across the resistor to vary what? Does it vary a thyristor, thermistor, resistance, or potentiometer? The resistance changes. That's basically like they got some resistive paint too that they use in some of them. Which of these components lets the PCM know how fast you want to accelerate? Yeah, that's right. Most of these are basically going to be TP sensor answers. Which of the following is a 3-wire variable sensor, potentiometer? The TPS is used to check the proper operation of which sensors? Both A and B, map and math. And like I say, a lot of vehicles have got both of them on there now, today. But, all right, you got that?
I see that.